When you conduct research about a group of people, it's rarely possible to collect data from every person in that group. Instead, you select a sample. The sample is the group of individuals who will actually participate in the research. To draw valid conclusions from your results, you have to carefully decide how you will select a sample that is representative of the group as a whole. There are two types of sampling methods. Probability sampling involves random selection, allowing you to make strong statistical inferences about the whole group. Non-probability sampling involves non-random selection based on convenience or other criteria, allowing you to easily collect data. You should clearly explain how you select your sample in the methodology section of your paper or thesis. First, you need to understand the difference between a population and a sample and identify the target population of your research. The population is the entire group that you want to draw conclusions about. The sample is the specific group of individuals that you will collect data from. The sampling frame is the actual list of individuals that the sample will be drawn from. Ideally, it should include the entire target population and nobody who is not part of that population. The number of individuals you should include in your sample depends on various factors, including the size and variability of the population and your research design. There are different sample size calculators and formulas depending on what you want to achieve with statistical analysis. Probability sampling means that every member of the population has a chance of being selected. It is mainly used in quantitative research. If you want to produce results that are representative of the whole population, probability sampling techniques are the most valid choice. There are four main types of probability sample. They are simple random sample, systematic sample, stratified sample, and cluster sample. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on chance. Systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. Stratified sampling involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. To use this sampling method, you divide the population into subgroups called strata based on the relevant characteristic, for example, gender, age range, income bracket, job role. Based on the overall proportions of the population, you calculate how many people should be sampled from each subgroup. Then you use random or systematic sampling to select a sample from each subgroup. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. If it is practically possible, you might include every individual from each sampled cluster. If the clusters themselves are large, you can also sample individuals from within each cluster using one of the techniques above. This is called multi-stage sampling. This method is good for dealing with large and dispersed populations, but there is more risk of error in the sample as there could be substantial differences between clusters. For example, in stratified example, company has 800 female and 200 male employees. Sample 80 women and 20 men to reflect gender balance accurately. In cluster example, company has 10 offices nationwide. Randomly select 3 offices as clusters and collect data from all employees there. In a non-probability sample, individuals are selected based on non-random criteria, and not every individual has a chance of being included. This type of sample is easier and cheaper to access, but it has a higher risk of sampling bias. That means the inferences you can make about the population are weaker than with probability samples, and your conclusions may be more limited. If you use a non-probability sample, you should still aim to make it as representative of the population as possible. Non-probability sampling techniques are often used in exploratory and qualitative research. In these types of research, the aim is not to test a hypothesis about a broad population, but to develop an initial understanding of a small or under-researched population. There are 4 non-probability sampling methods. They are convenience sampling, voluntary response, purposive sampling, and snowball sampling. A convenience sample simply includes the individuals who happen to be most accessible to the researcher. This is an easy and inexpensive way to gather initial data, but there is no way to tell if the sample is representative of the population, so it can produce generalizable results. Voluntary response sampling. Similar to a convenience sample, a voluntary response sample is mainly based on ease of access. Instead of researcher choosing participants and directly contacting them, people volunteer themselves, for example, by responding to a public online survey. Voluntary response samples are always at least somewhat biased, as some people will inherently be more likely to volunteer than others. Purposive sampling, this type of sampling, also known as judgment sampling, involves the researcher using their expertise to select a sample that is most useful to the purposes of the research. It is often used in qualitative research, where the researcher wants to gain detailed knowledge about a specific phenomenon rather than make statistical inferences, or where the population is very small and specific. An effective purposive sample must have clear criteria and rationale for inclusion. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. The number of people you have access to snowballs as you get in contact with more people. When choosing your sampling method in quantitative research, use probability sampling for strong statistical inferences and representative results. In qualitative research, use non-probability sampling to develop understanding of specific phenomena or small populations. Always clearly explain your sampling method in your methodology section. Transparency builds credibility. To conclude, probability sampling involves random selection. Every member has chance of inclusion. Strong statistical inferences representative results. It is often used for quantitative research and hypothesis testing. Non-probability sampling involves non-random selection. It is based on convenience or criteria. It is easier and cheaper. higher sampling bias risk, and it is best for exploratory and qualitative research.